Okay, guys, so I just kind of like woke up today and did like my normal stuff, and then I went on my YouTube, and you guys did something really weird. Uh, I just posted a video like for my college, for my professor, about my statistics project. It was literally just a project for the class, and you guys just like viewed it a lot. So, and ask questions and subscribe and like the video. So, I thought that I would explain the project a little more, and hopefully I can help you guys a little bit with your statistic project if you have to do one. I know I normally do real estate on this channel, but for the sake of this video, I am going to just explain that statistics project for you guys. So basically for this project, we had to sample people and ask them if they got the COVID vaccine or not. And based off of that data, we had to show a few different things, which I'll explain to you guys. So as you can see, the question was, have you received the COVID vaccine, which is a yes or no answer. The claim we got was from github.com, which 26.7% of Americans have been vaccinated. So we were going to see if the sample that we took was 26.7, if it was above or below that amount. So we did a random survey of 50 Americans to see who received the vaccine and who did not. So this was the questions. I don't think I really need to go too much into depth about this. It just seems pretty standard. So our alpha was 0.05 because that's the one that we use throughout the entire class most of the time. So I just said it's pretty standard. We did the population 16 years older because at the time that's the people that could receive the vaccine. Going to the graph, we did a pie chart. So we got 50-50. So 50 people said no and 50 people said yes. So when we did our pie chart, we just represented that. As you can see here, it says the total percentage of vaccinations based on 50% over the age of 16 have been asked on both responses, which totals 25 out of 50, which means 50% of Americans over the age of 16 that we received are all fully vaccinated, and 50% of Americans over the age of 16 that we surveyed are not fully vaccinated. So going on to HO and HA. HO equals 0.267 and HA is greater than 0.267. So what this is saying is the way we got 2.6 or 0.267 is from the test or the sample percentage up here from GitHub, the statistic right here. That is our HO because that is the sample, not the one that we did, not the random test, but from according to github.com. So we go down here, and what this greater than says is we think that it is above 0.267. So we express that through this here. So our HO is 0.267. That's what the statistic says, and we think that it is above 0.267 here. So moving on to the conditions, check the conditions. Condition 1, random and independent. Random is stated in the equation. So, or not in the equation, but when we were up here, I said we did a random survey of 50 Americans. So random is stated, so it is random and independent. Condition 2, large sample rule. The population is at least 10 times as large as the sample. So we do the population 10 times the sample size. So 10 times the sample size is 500. The sample size is 50 because we said we were doing a survey of 50 people. Do that times 10, that equals 500. All Americans that are 16 years old and older is definitely more than 500. So that proves that the large sample rule here. So going to condition 3, big population rule. So n times p is greater than or equal to 10. So we do the survey amount times the statistic, and that is greater than 10. So that works here. Here is the equation for that. We just plug in the numbers, our survey size, and then 1 minus the statistic, 0.267. We get 36.65, which is greater than or equal to 10. So both of these check out as well. I put it very simple for you guys. This is the SE equation here. So all we do is just plug in the numbers. PO is, again, the sample that we got from GitHub first. So we plug that in. We do 1 minus the sample again, divided by 50, which is our survey size, and we get 0.063, that is the SE. Okay, so going down here, P hat equals the sample statistic. So the sample statistic was 0.05, so we plug that in here and minus that by the statistic that we got from GitHub, divided by 0.06, that is the SE that we got up here, and we get 3.88. Moving on to the test statistic and the p-value. Here you can see that this is not explained. I did not do this part. But we can see here in the graph that this is the p-value based off of up here. So we do, the way that we get that p-value is by doing 100 minus 0.99, we get 0.01. So we put the z-score, which is what I got up here. We plug that in, and we shade to the right, and we get that 0.01% chance that HO is true. So 0.01% chance that this 26.7% is actually true. So write the conclusion of the test hypothesis test in the context of the problem. We do not reject HO. It is not significantly evident to reject HO. P-value equals 0.99. We conclude the portion of Americans who are over the age of 16 that are fully vaccinated is not greater than 99%. So we do not reject HO because HA is greater than HO and the p-value is 0.99. Going over here, we do the interval, which you can do on your calculator. And then we just did a paragraph reflection, which is not we don't need to go into that too much. So hopefully this helped you guys. If you want to know about the calculator, you'll have to look a video up on that because I don't have my calculator with me, so I won't be able to explain it to you guys. So I hope that helps you guys a little bit on your statistics projects. You guys really surprised me with that one by just engaging on my random statistics test project video. But I explained it a little bit better for you guys, so hopefully that can help you with your statistics projects. And we'll probably just keep posting real estate videos though from now on. But thank you for engaging with that video, and I'll see you guys soon, hopefully when I post my next video about real estate. Bye.